Hey everyone, today we are going to be doing Module 7 packet. I'm going to do about the first 3 pages in this video, and then you're going to see 3 pages in another video. I'm going to do it kind of in thirds, in 3 different parts for you. So the first topic that we have is we have identifying linear equations. So we have to determine which 4 of these are linear or not. Linear is something we've talked about in the past. We're looking at something that could be in the form of y equals mx plus b. So we're looking for x to be raised to the first power. If x is raised to anything else besides the first power, it is not linear. Also, we're looking for none of our variables to be in the denominator. So we have 4x minus 2 over y equals 7. If we were to try to get this into y equals mx plus b form, I would subtract 4x, and I'd have negative 2 over y equals 7 minus 4x. If I wanted to solve this for y, I can switch it with the entire other side, what we've done in the past, or I can cross multiply like what we just did. It would be negative 2 over 7 minus 4x equals y. Because that 7 minus 4x is in the denominator, we say that it is not linear. Okay? Because of that y being in the denominator, we don't want any of our variables to be in the denominator. Number 2, instantly looking at this, I have an x to the 4th. Anytime you have x raised to a power other than 1, it is not linear. Not linear. 6y equals x minus 4. If I divide everything by 6, I get y equals 1/6 x minus 4 over 6. This is in the form y equals mx plus b. This is linear. Same thing over here. If I have 1.1 equals 0.09x minus 0.7y, I could get y on one side by itself. So if I make this 1.1 minus 0.09x equals negative 0.07y and then divide everything by that, I would end up with y equals mx plus b, right? So that would be linear as well. So you're looking for variables in the denominator, variables in the exponent. You're also looking for any other power rather than 1 is not linear, right? Moving on, we're talking about functions now. For a relation to be a function, right, we are looking for each input to have no more than one output. So each input, that is domain. Domain's another name for input. Each input to have no more than one output. So one input goes to one output. If we have any inputs that output to more than one output, that is not good. So here, paper outputs to F and K because of the 2 lines here. Sun outputs to F, pencil outputs to K, moon outputs to D, tree outputs to S and N. So paper and tree both output to 2 things. That is not a function. Okay. Same thing over here with relation to sky outputs to Y, D, W, and R, and desk outputs to B. Because sky outputs to 1, 2, 3, 4 things, it is not a function, right? So not a function. We go to the bottom ones. Here we have the same thing we have up top, except we have it in a different way. Negative 9 is outputting to 1. Negative 7 is outputting to negative 7. 1 is outputting to negative 7, and 4 is outputting to negative 7. So -9 outputs to 1, -7 outputs to -7, 1 outputs to -7, and 4 outputs to -7. So each input, we're looking at the x values here. Each input only shows up one time. Now, what's confusing is that -7 outputs to -7, 1 outputs to -7, and 4 outputs to -7. There is no rule that states that they can't output to the same thing. You're only looking at one input, one output, one input, one output, one input, one output, one input, one output. So this would be a function. Another way to look at this is that the x value cannot repeat. So relation 4, we have 7, -1, -9, and -2. 7 outputs to 5, -1 outputs to 7, -9 outputs to 3, -2 outputs to -7. All right. Each input only appears once. It is a function. Now, if I added to it, if I said the point here, -1, 3. If I added on this point to it, -1 outputs to 7 and -1 outputs to 3. That would make it not a function, okay? But the function as it was a function, okay? Let's move on to the next topic. We're going to be talking about the vertical line test. Now, the vertical line test is used to determine if a graph represents a function or not. So, vertical line test, the rule is if I can draw a vertical line that crosses the graph more than once, it is not a function. So, I'm drawing a vertical line that goes up and down. That crosses the graph, this first graph, in 2 spots. That means that this input has 2 outputs. This x value has 2 y values associated with it. That is not a function, okay? Same thing over here. If I draw any vertical line that crosses it more than once, that is not a function. Okay? These dots can be a little tricky sometimes. You have to be really careful. If I draw a vertical line here, it crosses once. A vertical line here, it crosses once. A vertical line here, it crosses once. But if I draw a vertical line here, it would cross twice, making it not a function. Down here on this next one, right, if I draw vertical lines anywhere on this, it just crosses once. So therefore, this is a function. Same thing over here. If I draw a vertical line, can I get a vertical line to cross 2 dots? No, right? All of them just cross one. That is a function. Now, what about a circle? Okay. I can draw a vertical line out here that doesn't cross any of them, right? I could draw a vertical line here that just crosses it once, but I could draw a vertical line here that crosses it twice. If any vertical line crosses it more than once, it is not a function. All right, let's move on to domain and range in set notation. All right, so suppose that the relation T is defined as T is the set of 9B, 9D, and 8A. Give the domain and range of T. Write your answers using set notation. Okay, set notation. That's the tricky part of this, the set notation. So your domain would be squiggly. You're looking at 9, 9, and 8. And then your range would be B, D, and A. Okay. Let me just look real quick to see if that is what they want for set notation. They might want something else. Okay, that does appear what they're looking for. All right. Domain is another name for the X values, these first values here. Range is another name for the Y, that B, D, and A. They might not want you to repeat your domain here. I know Alex can be a little picky sometimes, so you might want to, they also might want you to write it in an order here. So we might just accept that it is 8, 9. Our range, they might want that in alphabetical order. They might want A, B, and D. Okay, so just be aware of that they might want it in a particular way. Me personally, I'm good with just that. So domain should be all the X values, range should be all the Y values. Okay. Our next topic, it says table for linear functions. So we are given a function g of x equals negative 5x plus 4, and we have to complete this table. Those of you that are comfortable with a graphing calculator or have a graphing calculator at home, you can plug in negative 5x plus 4 into the table and then get these as the output, or into the y equals and then get that outputs in a table. Those of you that don't have a graphing calculator at home, what you're going to do is you're going to be plugging in negative 5, negative 3, 0, 1, and 5. So g of negative 5, that's plugging in negative 5 into g of x, would be negative 5 times negative 5 plus 4, which would be 25 plus 4, which is 29. Then g of negative 3, we have negative 5 times negative 3 plus 4, looking at 15 plus 4, which would be 19. Then g of 0, so that's negative 5 times 0 plus 4, which is going to be 0 plus 4, that'd be 4. Then g of 1 would be negative 5 times 1 plus 4, which is negative 5 plus 4, which is negative 1. And then g of 5, we have negative 5 times 5 plus 4, which would be negative 25 plus 4, which would be negative 21. All right, all they want you to do is fill in that table based off of this function. So plugging in the x values, getting the y values out. All right, let's go to the next topic. All right. Number 9, evaluating functions, linear, quadratic, and cubic. All right, so it says the functions f and g are defined as follows. So they give us one function, f of x is negative 2x to the third minus 3, and then g of x is negative 3x plus 2. We have to find f of 5 and g of 4. So f of 5, this f means that we're using the function f of x. We are only plugging 5 into f of x. So f of 5 would be negative 2 times 5 cubed minus 3. While g of 4, we are using the g function for that. So that would be g of 4 equals negative 3 times 4 plus 2. Okay, so we're only solving the right side. Don't do anything with this left side of these, because that tells you what you're trying to solve for. This 5, some people make the mistake and divide their answer by 5 at the end, or divide their answer by 4 at the end to get g and f by itself. You don't have to. Just leave it as f of 5 and g of 4. So we have 5 to the third power. That's 5 times 5 times 5. So that'd be negative 2 times 125 minus 3. Negative 2 times 125 would be negative 250 minus 3. you're looking at an answer here of negative 253. And then g of 4, you're looking at negative 3 times 4 plus 2. Negative 3 times 4 is negative 12. Negative 12 plus 2 is negative 10. So g of 4 equals negative 10, and f of 5 equals negative 253. All right, here we have some word problems. Now, the good thing about these word problems is they are already giving you the function. So you do not have to create your own function here. Just look at what they give you. So it says a printing service charges a setup fee of $8.25 for each order and 7 cents more for each copy. The total cost C in dollars for an order of X copies is given by the following function. Here you can see the 7 cents per copy plus the $8.25 for the setup fee. What is the cost for an order of 50 copies? So 50 copies, that would be the X. That's what the X value stands for. So all they want us to do is find what C of 50 is. So 0.07 times 50 plus 8.25. So 0.07 times 50, I'm going to take out a calculator. 0.07 times 50 is 3.5 plus 8.25, and 3.5 plus 8.25 is 11.75. So 50 copies would be $11.75. All right, so we're just using that equation they give us and then plugging in that value of X. Here we have another version of it. It says Dan rented a truck for one day. There was a base fee of $13.25, and there was an additional charge of 10 cents for each mile driven. The total cost C in dollars for driving X miles, right? So X stands for miles, is given by the following function. So C of X, so the cost of driving X miles is 0.10X plus 13.25. What is the total rental cost if Dan drove 20 miles? So what do they want us to do? They want us to plug 20 in for X. So C of 20 is 0.10 times 20 plus 13.25. So 0.10 times 20 is 2, and 2 plus 13.25 is 15.25. So what is the cost of driving 20 miles? That would be $15.25. Easy enough if they give you the functions, which they're going to. Okay, the last topic we're going to get to on this video is we are going to be talking about the domain and range of linear functions that model real-world situations. So we have to state what description value is the domain and range and state the value set for each. Okay, so it says here a small publishing company is planning to publish a new book. Let C be the total cost of publishing the book in dollars, and let N be the number of copies of the book produced. For the first printing, the company can produce up to 300 copies of the book. Suppose that C equals 25N plus 600. Give C as a function of N during the first printing. Identify the correct description of the values in both the domain and range of the function. Then for each, choose the most appropriate set of values. I believe on Alex, this is a multiple choice for you, but we're going to go through how to do it. So the domain. So what are we plugging in? What is dependent here? So we're looking at N being that value of that we would plug in, all right? So N stands for the number of copies of the book produced. So our domain would be N. So our domain would be the number of copies of the books produced. So domain would be copies produced. Now, we were told that the printing company can produce up to 300 copies of the book. So that means we can print, so the most that we can print is 300 copies of the book. So our domain would say that N has to be less than or equal to 300. So the number of copies has to be less than or equal to 300. Now, when we're dealing with our range, that's our output, that's our cost. Okay, C, let C be the total cost of publishing the book. So range would be the cost. Now, we have to look at it this way. Actually, N has a limit here. We can't produce a negative amount of books. We can produce 0 to 300 of them. So we're from 0 to 300. You can't produce a negative amount of books, which is why that 0 is needed here. So what is the cost of producing 0 books? 0. Okay. Then what would be the cost of producing 300 books? So if I plugged in 300 to our cost function, I'd have 25 times 300, which would be 7,500 plus 600. You're looking at 8,100. So if the most we can produce is 300 books and it costs $8,100 to produce the 300 books, then our range, which represents the cost, is from 8,100 to 0. So from 0 to 8,100. So our domain is represented by it can only produce up to 300 copies. So that would be from 0 to 300. But our range is based off of the cost, what this equation would be. And if you plugged in 0 into this, you would get 0. If you plugged in 300 into this, you would get the 8,100. Okay. That's it for this part. Okay. I will be doing the rest of it in another part of the video. So it's in smaller chunks for you so you don't get overwhelmed. Okay. Good luck. Go and work on those topics and watch the second video when you're done with those topics. Thank you.